Welcome, ladies and gentlemen. So what I'd like to do is just kind of review with you how to solve different sides of a right triangle using the Pythagorean theorem. Now, remember, Pythagorean theorem only works when we have a right triangle, meaning that we have a right angle. And when we have a right angle, we can organize the sides of the triangle. So if you determine that here's the right angle, which usually is going to be given to us, the side across from it is going to be our hypotenuse. And in this case, you guys may formerly known the hypotenuse labeled as the side that's C. Then there's two sides that also make up your 90-degree angle. Those are what we call the sides. That's the hypotenuse. These are called your sides. And the sides we a lot of times commonly refer to as sides A and B. So therefore, if you remember the Pythagorean theorem, there's a relationship between the length of the sides and the hypotenuse. And that relationship is a squared plus b squared equals c squared. So when I'm going to be doing these problems, what I'm going to do is I'm going to want to first make sure I always identify what the hypotenuse is as well as what are the two sides. Now you can see in this case that we have x is going to be our missing side. Okay, so rather than using always a, b, and c, I have x. So I'm not actually going to use a, b, and c, but it's just to note that side squared plus side squared equals hypotenuse squared. All right, so let's go ahead and take a look at our first problem here. And on our first problem, again, when I look at a 90, anytime I see a right triangle, the first thing I want to do is identify where's the hypotenuse. So I can see my hypotenuse here is x squared. Now remember, I said that side squared plus side squared equals my hypotenuse squared, which is x. So my two sides are 5 and 12. So I have 5 squared plus 12 squared equals x squared. Now, it should come to notice, it should be aware to you, and I have another video of many of these examples, is this is actually a Pythagorean triple. And when doing a Pythagorean triple, you don't even actually have to do the Pythagorean theorem. If you see that it's a Pythagorean triple, you can easily see that the answer is 13. However, for those of you who might say, what are you talking? How did you get 13? Let's actually go through the problem. So the first thing you do is square your 5 and your 12. So I'd have 25 plus 12 squared is 144 equals x squared. Then I add 25 plus 144. That's going to give me 169 equals x squared. Then, to go ahead and solve for x, I now need to use the inverse operation of squaring, which will be the square root. And therefore, I get 13 equals x. And it's going to be positive. It's not going to be the negative form. So therefore, you can see that 13 is going to be my hypotenuse. All right, so now let's go and take a look at this next example. In this next example, you can see that now I'm actually given my hypotenuse. In this case, my hypotenuse is actually 8. So I can see that and my two sides are going to be 4 and x. So again, remember, it's side squared plus side squared equals your hypotenuse squared. So I'll have 4 squared plus x squared equals 8 squared. Now, before I move forward, now I'll just simply go ahead and square each and every one of those terms. So 4 squared is 16 plus x squared equals 64. OK? Now, I got to solve for x squared, right? So in this case, I'm going to have to subtract a 16. And I get x squared equals, 48. So now, I need to go ahead and take the square root. So to undo, just like I did before, I need to take the square root here. So you can say x equals the square root of 48. But it's important here to understand that, well, you always want to look into always simplifying. So in this case, I can break up. I can't take the square root of 48. However, I can take the square root of 16. And 16 goes into 48 3 times. So therefore, now I can rewrite this as x equals the square root of 16 is 4 square root of 3. So whenever you have the opportunity to simplify your answer, always do. So always make sure you remember how to do that. In the last example, I picked this one I like because a lot of times students are like, all right, I get the Pythagorean theorem. It's pretty easy. It's either you find the two side squares and you're finding the hypotenuse, you're squaring them, and it's either a Pythagorean triple, so you're going to have a integer as your answer, or you're going to do Pythagorean theorem and you're going to have to solve for the side by subtracting, and then you might have an answer that's going to be irrational, so you have to simplify it. And then you have ones that are like mixed in the diagram. And the main important thing is just understanding that we only want to focus on the right triangle. I have this big triangle here, but we're trying to find the value of x, which is just this side length. That is contained within this triangle. So yes, there's this triangle here, which I'm just going to kind of like fade out. But that's not really a part of the problem. It's just kind of there. It's a part of the problem, but it's not really going to affect our problem at all. All we're simply doing is applying the Pythagorean theorem for this certain triangle right here, where you can see that 10 is my hypotenuse, and 7 and x are my two sides. So again, Pythagorean theorem, side squared plus side squared equals hypotenuse squared. So I have x squared plus 7 squared equals 10 squared. Now I square every term. So I have x squared plus 49 equals 100. Now to solve for x squared, I subtract 49. And I have x squared equals 51. Now to undo the squaring, I'll take the square root of both sides. And you see x equals the positive root of, or the positive square root of 51. However, unlike this problem where we are simplify, this one, there's no squared numbers that I can do. I can't break down 51. 51 is a prime number. So therefore, that's going to be our final answer. So there you go, ladies and gentlemen. That is how you determine the missing sides using your Pythagorean theorem. Thanks.